Okay, hello guys, this is Mr. Abdurrahman with a small video, quick short video for you as grade 8 or grade 7, and this one is designated for grade 8 to explain a few things, a few quick things to you. So it's going to be more like brainstorming. Since the beginning of this unit, we talked about that we're not going to use the bit just to explain things. We said that if I want to store the word cat inside of my computer, the word cat consists of 3 letters, and each of these letters require 1 byte to be stored. So the total amount of size that should be acquired or allocated to store that word is going to be 3 bytes. Also, we said that the 1 byte is actually representing 8 bits. The bit was something we used when we talked about colors and representation of visual online graphics. Beside that, we have less common used unit. It's called the nibble, and it's actually requiring, or it's actually equivalent to 4 bits. So sometimes you need to convert from one to another. Just remember that if you wanted to express the 1 byte as nibbles, remember that the 1 byte is actually consists of 2 nibbles. Well, this is all you need to convert with these small units. Okay. We said that sometimes we're gonna deal with something larger. So sometimes I'm talking about size of a file. I'm talking about like 16 gigabytes, or I talk about 3 kilobytes. Sometimes I say, because this kind of sizes is familiar when we use 100 megabyte. But when it comes to the binary, we are using something else. We don't use these units, despite the fact that they are close to what we are using, because the kilobyte here is equal, actually the kilobyte is equal to 1000 byte, while the megabyte is equal to 6 zeros bytes, which is a million. So the gigabyte is actually consists of 9 zeros as bytes. Yeah. When it comes to the binary, we don't use these units. We use something called the kibibytes, refer to it as this, and we use the mebibytes, refer to it as MIB, and we use the gigabytes. You need to understand that these values is equivalent to the other. This is going to be equivalent to 1000, and the megabyte is equivalent to 1 million, while the gigabyte is equivalent to a billion. So how you might use this kind of thing? If I say that I'm going to give you a movie that has a file size of 3.4, and let's just say gigabyte or gigabyte, whatever you want to call it, and I asked you to fit it in. I said that copy as many as that of that movie in a 16 gigabyte flash drive. So by the calculation, you understand that you cannot fit more than 4 of them, because when you multiply 4 by 3.5, you're gonna have something close to this one, 13.6, which is less than 16, but you cannot fit more than that. So you say that I can fit 4 files in that flash drive. So this is the thing that you need to consider. Also, we say that the number that we are using is referred to as base 10, while there's something called base 2. This one is referred to as Denary. This one is referred to as binary. How we use both of them? We said that we use the base of 10 here to represent our values. What does it mean? That means that we represent, if I said that I'm gonna write 245 as a value of numbers, they represent, these are the digits and these are the these are the digit value. We say that we cannot, if I say that write down the digit value of this one, or the place value of the 5, you will say that 5 is actually representing 5 multiplied by 10 to the power of 0. while this one is going to be 4 multiplied by 10 to the power of 1, and this one is going to be 2 multiplied by 10 to the power of 2. What does it mean? That it means that if you're doing the calculation, you're going to find out that this is equal to 5, this is going to be equal to 40, this is going to be equal to 200, which is actually representing a fact that this is 200. That's the value of the 2, and the 4 has the value of 40. We're talking about the value, so you need to understand each number. If I say write 245 as a product of its consists of powers of with a base of 10, you will say that it's going to be equal to 5 multiplied to 10 to the power of 0 plus 4 multiplied to 10 to the power of 1 plus 2 multiplied by 10 to the power of 2. Sometimes I'm going to ask you for something like this, or sometimes I'm going to ask you to fill or complete the table of values. Now, when we talk about this from the perspective of the binary has a different story, because the binary is not using 1, 10, 100 as a weight for the digit slot. It's using something consists of 2 to the power of n. What is the meaning of that? It means that the first one is going to has the digit or has the weight of 2 to the power of 0. The next one 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and this one's going to be 2 to the power of 7. When you think about them as values, it's going to be 1, 2, 4, 8, 16, 32, 64, 128. We're not going to talk about more than that, because this is the scope of our study. If I asked you to write this as a product consists of a base 2, you will say, if I say that I have this number, okay, and I ask you to write this number as a product of its base 2, you'll say that this one, first one is going to be consist of 1 multiplied by the weight, which is 2 to the power of 0, okay, which is going to be equal to 1. So this one is going to be 0 multiplied by 2 to the power of 1, which is going to be 0. And we do the same with everything that consists of 0, because it's going to be, unless you're completing the table, but other than that, I don't need it for my calculation. And if I did the same thing here, if I multiplied 1 by 2 to the power of 2, you will notice that this is going to be equal to 4. So basically, every time you're multiplying, you're going to get the value underneath the table. So using that concept, you know that this is going to be equal to 8. So we're going to write it down on top. So this has 1 plus 0. We're trying to explain how you can find the equivalent denary for this binary. This is a binary number, and this is the method that you use. That's why we are studying the place value grid, so you can convert from binary to denary and vice versa. So this is going to be 1 plus 0 plus 4 plus 8 plus 0 plus 0 plus 64 plus 0. So the idea that you'll notice that 0, 1, 0, 0, 1, 1, 0, 1 is actually equivalent to what? It's actually equivalent to 64 plus 8 plus 4 plus 1, which is equal to 64 plus 13, which is going to be equal to 7. 77 is the equivalent denary for this number. So this is the binary, and this is the denary equivalent to it. Clear? Now, how we can do the opposite? Let's say that I gave you a number, and it's going to be something like, we'll say that we're going to use something like 132. And this is representing a denary, and I ask you to convert it into a binary. How you can do that? Basically, we'll try to use the weights of the binary. Say that the first digit in the binary consists of, we're talking about the binary that consists of 8 digits. It's going to be 1, 2, 4. This is the weight of the digit of the binary. Okay. Now you're trying to convert 132 into a summation, process of summation that consists of one of these numbers, because you cannot use anything but them. So 132 is actually more than 128, so you can represent it as 128 plus something. It's gonna be plus 4, as you can see. So what is the meaning of that? It means that we used this digit beside this digit to represent our number. The equivalent of these weights is going to be written as 1. So we're going to write 1 and 1 because they are switched on, because these values exist as part of the number 122. The rest of the digits that doesn't have an equivalent as part of the summation, we're going to write zeros in front of them. So what is the meaning of that? It means that this number, the denary, has an equivalent of binary as this. This is the equivalent binary of the given denary. I hope that this video was useful for you. See you in other videos, but sorry I cannot explain any further than this. It's actually exceeding the 10 minutes limits. See you in other videos, and good luck with your examination tomorrow. Take care, guys.